We have a vector valued function r, which is a function of the parameter t. T is a scalar parameter. We need to find the values of the first derivative of our vector r, its magnitude, and also the second derivative of that vector and its magnitude at t equals to 0. So let us begin. First, let's consider our vector valued function r. So that's given by t squared. So this is the x component of r. Then we have negative t. So negative t is going to be the y component of the vector. And the z component is 2t plus 1k cap. So let's label this as equation number 1. Now, we will take its derivative with respect to t of this vector valued function r of t. For that, all we have to do is apply the derivative to each of the three terms. And if we look at each of the terms, we have a product. We have a product between, for the first term, t squared and I cap. In the second, it's a product between t and j cap. And in the third, it's 2t plus 1 times k cap. So that means we need to apply the product rule here. However, our vectors I cap, j cap, and k cap, these three are constant vectors. So that means if we take its derivative with respect to t, that will be equals to 0. And this is equally true for the two vectors, that's the unit vector j cap and the unit vector k cap. So the derivative with respect to t is also going to be equals to 0. So we'll only take the derivative of the coefficient of I cap, j cap, and k cap. The derivative of t squared, so that will be 2t. So we have 2t I cap minus derivative of t, so that's 1. So we have 1 j cap plus derivative of 2t plus 1, so that's 2k cap. So let's call it equation number 2. Well, let's find out the magnitude of this first derivative of r with respect to t. So for finding out the magnitude, all we have to do is take the square root, and then we'll take each of the components, square it, and then add them to each other. So that gives us square root of 4t squared plus 5. Now we have to find the values at t equals to 0. So we'll come to that at the end. So let's first compute all the required derivatives. So we will next compute the second derivative of r with respect to t. For that, all we have to do is take equation number 2 and take the derivative of each component with respect to t. So that will be also referred to as the first derivative of the first derivative of r. Means the same thing. This will be 2t. So that's derivative is 2. So we have 2 I cap, and rest of them will be 0 because 1 is a constant, 2 is a constant. Right. And its magnitude, so d squared r over dt squared, its magnitude will be square root of 2 squared, rest of them are 0, so this is 2. Fine. Now we will finally compute each of the values at t equals to 0. So that means first let's compute the value of the first derivative of vector r computed at t equals to 0. So this will be equals to, so let's take equation number 2, and wherever we have t, we'll replace it with 0. So we have 0 I cap minus j cap plus 2k cap. Then the magnitude of the first derivative of vector r computed at t equals to 0. So that will be equals to, so this is the 1 magnitude. So we have 4 times 0 squared plus 5. So that means this will be square root of 5. Then coming to the second derivative, with respect to t, so this will be equals to 2 I cap, and magnitude with respect to t computed at t equals to 0. So that's equals to 2. Same goes for the second derivative here, computed at t equals to 2. This will be 2 I cap.